So in this lesson, we're going to take another look at geometric vectors here. And what we want to talk about here are the components of a vector. So what do we mean by the components of a vector? How do you take a vector and break it down into its components? And if you have the components of a vector, how do you combine them back together to get a single vector? And then eventually, we want to be able to use what we've learned about components in order to use them to add vectors together. And this gives us another way of adding vectors. So first off, let's just say what we mean by components here. Any vector can be thought of as the sum of two other vectors that are perpendicular to each other. These two vectors add together to make up the vector that we are interested in. So these are called the components of the vector. So if I've got a vector v here, and I want to think about it in terms of its components, well, I need to have two vectors that are perpendicular to each other that add to give me vector v. So I'm going to have a vector that is vertical and a vector that is horizontal. And so we call one of these vectors the vertical components, and one of these the other vector the vertical and the horizontal components. Or, as I like to say, we usually use the x and the y components. Okay. So this I'll call vector y, and this one I will call vector x. And we're sort of assuming our standard coordinate system here, where over towards the right here is the positive x direction, and going up is the positive y direction. So this would be negative x. This would be sort of negative y down here like this. So if we've got these vectors x and y, we can sort of write that vector v here is the vector sum of vector x and vector y. And what we're asked to do over here is find the magnitude and direction of vector v. Now, how can we do that? Well, looking at our diagram here, we can see what the magnitudes of our two component vectors, x and y, are, just by making reference to the grid here. The magnitude of vector x is 1, 2, 3, 4. The magnitude of vector y is 1, 2, 3, 4, 5. So we know that by Pythagorean theorem, the magnitude of vector v squared is going to be, well, because this is a right-angled triangle, knowing that these components are perpendicular, the magnitude of x squared plus the magnitude of y squared will give us the magnitude of v squared. So just finishing this off, we're going to have this magnitude of vector v is going to be the square root of 4 squared plus 5 squared, which when you work this out, you find the magnitude of v is root 41. Now, what about the direction of vector v? Well, when we specify the direction of a vector, when we're dealing with components, we're going to be very specific about what we say, how we specify that direction. For the direction, we want to give the angle from the positive x-axis to the tail of the vector. Okay, so we want to think of our vector as an angle in standard position, if you think back to advanced functions. So the angle that we want to give here is going to be this angle here, measured from the horizontal, positive x direction, up to our vector v. So how do we figure out what that vector is going to be? Well, again, this is some simple right-angle trigonometry here. We know that the tan of angle theta is going to be the opposite over the adjacent. So it's going to be the magnitude of vector y over the magnitude of vector x. Okay, so in this case, tan theta is 5 over 4. And so theta, punching this into our calculator, gives us 51.3 degrees. So there we have the magnitude and the direction of vector v. Magnitude is root 41. The direction is 51.3 degrees from the positive x-axis. Now we can also go the other way. if we have a vector, we want to be able to find the components of it. So given vectors v and w here, let's try to find the components of each one of these vectors. Let's start with vector v here. I'm just going to bring this down onto our coordinate axis here. And its components are going to be two vectors that are perpendicular to one another. Okay? So again, I'm going to say, well, we can have a vector coming down here like this. This is going to be our y component, and a vector over here. This is going to be our x component. So for vector v, should get some black. For vector v, we can say that v, and I'll use this little subscript x to indicate the x component. We know that it's going to have a magnitude of 4. We can read that, 1, 2, 3, 4. What about the direction of this vector? Well, our horizontal component, our x component, is always going to go in, it's always going to be going horizontally. So it's always going to be going either in the positive x direction or in the negative x direction. So again, positive x is to the right, negative x is to the left. And just to fill this in, positive y is up, negative y is down. So our x component here is traveling to the left, so it's going to be negative because it's traveling in the negative x direction. So this is not just the magnitude of the vector. The magnitude of the vector is 4. The magnitude, the direction of the vector is given by the sign. So vx here, the x component of vector v is a vector in this notation. Okay? We can also specify the vector that represents the y component. It's going to be negative 2. A magnitude of 2, it's going in the negative y direction. And what about vector w? We can bring it down onto our coordinates as well. We can see that when we try to break w into components, we see that w is just pointing in the horizontal direction. It isn't going up or down in the vertical direction at all. So its horizontal component, wx, is going to have a magnitude of 1, 2, 3, 4, 5. And it's going in the negative x direction. Its y component, well, its y component doesn't exist. It has a magnitude of 0 because the vector isn't going up or down at all. So we don't really have, so the y component is going to be 0. Now, this is pretty straightforward when we've got the coordinate grid to work with. What if we have to do this a little bit more algebraically? So let's say they just tell us, hey, the vector has a magnitude of 10. It makes an angle of 52 degrees to the positive x-axis. Let's find our components. Well, this is going to be another exercise in right-angle trigonometry. First, let's put in the vectors that represent our components. We're going to have an x component, and we're going to have a y component. And let's just change the size of this so they match up like this. And we will label these. This is x, this is y, and of course these are at a right angle. So if we know the magnitude of w is 10, and we know that that w makes an angle of 52 degrees to the positive x-axis. That means the angle between our x component, which is going in the positive x direction here, this angle here must be 52 degrees. So now we can figure out how big our components are. We can say that if we look at that angle, 52 degrees, if we just think of that in terms of theta, cos theta, that angle, would be adjacent over hypotenuse. So our adjacent here is x. So the length of the adjacent side is the magnitude of x. The length of the hypotenuse is the magnitude of w. So the magnitude of our x component is going to be, just rearranging this, the magnitude of the vector w times cos theta. or in this case 10 times cos 52 degrees, or working this out, 6.16. Similarly, if we want to find our y component, we can notice that the sine of that angle theta is going to be opposite over hypotenuse. So the opposite side is that vector y. So magnitude of y represents the length of that side, and again, the length of our hypotenuse is the magnitude of sine w. So the magnitude of our y component is going to be the magnitude of our vector, magnitude of w, times sine theta. And we can work this out. 10 sine 52 degrees, which, punching this into our calculator, gets 7.88. So what are the vectors that represent our two components? Well, our x component is going to be positive 6.16 because it's pointing in the positive x direction. And our y component is magnitude of 7.88 in the positive y direction. So those are our two components. So just to summarize the key formulas that we had here when we were working with components, we got our vector v, we can break it up into our x component and our y component, which are perpendicular to each other. We used Pythagorean theorem to find the magnitude of v. We used the tan ratio to find that angle theta, where theta is measured from the positive x-axis up to our vector. And when we were going the other way, we found our x component and our y component using right-angled trigonometry, sine and cos.